So in this video, we're going to look at solving quadratic equations. So quadratic expressions typically have that form ax squared plus bx plus c. And what really makes it quadratic is this x squared term and the fact that that's the highest degree, in that if you have x cubed, then it becomes cubic. So x squared is present and it's the highest degree. So if we look at our example here, what we can see is we have x squared in there, so this is going to be quadratic. So our first step is that we want to collect everything on one side of the equation so that we have 0 on the other side. We want to get to this form where we have ax squared plus bx plus c equals 0. So looking at this equation here, typically I want to keep x squared positive. That's helpful for when we get to factoring. So it's really this negative 7x that I need to move over to this left-hand side. So I'm going to do is add 7x to both sides of the equation. So we'll have x squared plus 7x plus 12 equals 0. So it'll help to have it in order like the ax squared plus bx plus c for our next step where we factor. So we have to have 0 on one side of the equation, then the other side we have our quadratic, and we're going to factor that quadratic expression, and then we'll have that equal 0 on the other side. So this will be made up of an x plus 3 and an x plus 4. If we multiply those, that will be our factored form. And our next piece that we want to use is the zero product property. We have these two things multiplying together, and when they multiply, they equal 0. Now, if we say that with these numbers a and b, if we have a times b equals 0, what that tells us is that one of these has to be equal to 0. We either have 0 times b or a times 0. So we get to split into these two cases where a is equal to 0 or b is equal to 0. Same thing is true here in this factored form. It's the idea that this x plus 3 must be equal to 0 so that it multiplies and gives us 0 out, or x plus 4 has to equal 0 so that when they multiply, we get 0 out. So what we end up doing is splitting our equation. We end up with two possibilities. X plus 3 is equal to 0, or x plus 4 is equal to 0. So we end up with these two equations, and then we solve. So on this left-hand side equation, I'm going to subtract 3 from both sides. So that would tell me that x is equal to negative 3. On this right-hand side equation, we would subtract 4 from both sides, and that would tell me that x is equal to negative 4. So let's check this. What we end up with is two checks. We would plug in x equals negative 3, so we want to look at negative 3 squared plus 12 and see, is that equal to negative 7 times negative 3? We also want to see if negative 4 works. We have negative 4 in parentheses squared plus 12. Does that equal negative 7 times negative 4? So let's see. We can go to a calculator and look at negative 3 squared plus 12 and see, is that the same thing as negative 7 times negative 3? And it is. So that checks out right. Then we do the same thing for negative 4. So negative 4 squared plus 12. And is that the same as negative 7 times negative 4? It sure is. So both of those answers work. So those are the steps we want to go through. First step is get 0 on one side of the equation. Then we want to factor. And then we're going to split into these two cases where we can solve and get two solutions out. So let's try that out with some examples down here. So we already have 0 on one side of the equation. So we're done with step 1 already. What you'll notice is we don't have a constant term. We don't have a plus c here. So what we can do is just take out the greatest common factor. So we have this common factor of x. So let's go x factored out, and then we'd be left with x plus 5 equals 0. Now we still end up with that zero product property because we have these two pieces multiplying together. We have x times x plus 5 equals 0. So that means x has to be 0 or x plus 5 has to be 0. So we do split into these two cases. And if it helps, you could even kind of visualize parentheses there around the x. But we're going to have x equals 0 or x plus 5 equals 0. So we're done with this first one. X is equal to 0. On this right-hand side, we need to subtract 5 from both sides. So that's going to show us that x equals negative 5. And then we could just do a quick check on the side here. So if we plug in 0, so 0 squared plus 5 times 0, does that equal 0? It sure does. If we plug in negative 5, so negative 5 squared plus 5 times negative 5, and does that equal 0? Well, negative 5 squared, and be sure to use those parentheses, because that'll be positive 25, and then positive 5 times negative 5 is negative 25. So does that equal 0? And it sure does. So that all balances out. So 0 is a solution, and negative 5 is a solution. Okay. Sometimes you'll need to do some simplification first. I mean, I could go ahead and subtract 4 and get 0 there, but let's go with the distributive property first. So x times 5x is 5x squared, and then plus 8x equals 4. Then I can really see that we do have a quadratic here and not a linear equation. Then I need to get 0 on one side, so I'm going to subtract 4 from both sides. So we have 5x squared plus 8x minus 4 equals 0. Now we want to factor, so I'm going to use the AC method that we talked about. So taking 5 times negative 4, so I want to look at the factors of negative 20 and see which ones would give me 8, and it's going to be a negative 2 and positive 10. So I'm going to do is split up that term of 8x there. So I have 5x squared minus 2x plus 10x minus 4 equals 0. Then I'm going to factor by grouping. So I'm going to cut the expression in half. On the left-hand side, I have a common factor of x. So I'll give me a 5x minus 2. On the right-hand side, I'll have a positive 2, which will leave me with a 5x minus 2. And then we still have that equals 0. So be sure to not drop the equation. In factoring, we've practiced going through this left-hand side, but now we have this extra piece that this is an equation. It's just not changing, but you always have that equals 0. All right, we have this common factor of 5x minus 2. So we'll factor out 5x minus 2, and then we'll have these leftovers of x plus 2, and then we still have that equals 0. So we factored. It's just a longer process with this AC method, but we get to our two factors, and the idea is that at least one of those has to equal 0. So 5x minus 2 equals 0, or x plus 2 equals 0. And then we're going to solve them. So we'll add 2 to both sides for this one. So we'll have 5x equals 2. And then divide by 5. So that tells me that x is equal to 2/5. On the right-hand side one, we'll subtract 2 from both sides. So that tells me x is equal to negative 2. And then we should check our answers so that we know with 100% certainty that we got these right. So with this one, especially with fractions, I like to just go to the calculator. So for the left-hand side of the equation, we have 2/5 times 5 times 2/5 plus 8. And we can see that does come out to 4. So that is Perfect. And same thing with -2. So -2 times 5 times -2 plus 8. And I did something wrong there. There we go. Multiply. There's our +4. So that all balances out. So that's our solving quadratic equations using factoring.